the integral which you are seeing is really interesting integral. So let's see how we can evaluate this integral. So it's the integral of the function x square minus 1 divided by ln x dx evaluated from 0 to 1. So there can be multiple approaches for this problem, but I'll be telling you using Feynman technique. So using Feynman technique, what we will do is that we will assume that instead of this integral, we have this integral 0 to 1 of the quantity x to the power alpha minus 1 divided by ln x dx, and we set it equal to some I of alpha. Okay, so now we will get the result in terms of alpha. So let's see what we get. So let me draw the line over here. So it is like this. So now we have this integral. So let's differentiate it, right? So what is di by d alpha? It will be equal to d by d alpha of the quantity, this integral, minus 1 divided by quantity ln x dx, right? So now when you bring this term inside the integral, it will become the partial derivative, and when you take its derivative, you will get integral from 0 to 1 ln x to the power alpha divided by ln x dx, and you will get the result as 0 to 1 x to the power alpha dx, and once you integrate this, you will be getting it as very simple result. It will be equal to x to the power alpha plus 1 divided by alpha plus 1 evaluated from 0 to 1, which is equal to 1 upon alpha plus 1. So we have di by d alpha is equal to this expression. So we can clearly say that from here we can say that di is equal to 1 upon alpha plus 1 d alpha, and when you integrate it, you will get your I of alpha. It is equal to natural log of modulus of alpha plus 1 plus some arbitrary constant. So this is the value of integral, but how we can evaluate the value of c over here? Well, we know this function, so let's substitute alpha as suppose I use alpha as 0, because if I use 0, it will become 0. Integral of 0 is 0. So if I use this integral 0 to 1 x to the power alpha minus 1 divided by ln x dx is equal to I of alpha, and I evaluate it at alpha is equal to 0, I will get I of 0 is equal to 0, right? Correct. So from here we will substitute alpha is 0, so we have I of 0 is equal to natural log of 1 plus some arbitrary constant, hence c is equal to 0, correct? And since c is equal to 0, so we have the integral I of alpha is equal to natural log of modulus of alpha plus 1, and since we know that in this case alpha is equal to 2, hence I of 2 is equal to natural log of 3, and that is the answer.